Well, next up is a discussion of triple integrals and applications, so we're going to discuss that.
Shall we?
Yes, we shall. So, if we have a solid region Q that's a region in R cubed, as this light blue piece right here is, that's representing a solid region, we can chop it up into small rectangular solids with planes parallel to the coordinate axis, parallel to the y-axis, parallel to the x-axis, and parallel to the z-axis. The sum of all those rectangular prisms would approximate the volume of a solid like this. And of course that would mean we'd be letting the rectangular prisms volume approach zero. So if there's a function we could evaluate at a point inside each of these small parallelepipeds, if you want to call them rectangles you can, rectangular solids I guess would be a better word, then we can approximate an integral over the solid region by summing the products of the function evaluated at some point in each solid and the volume of the parallelepipeds for each parallelepiped. The sum of all those products would approximate the integral of the function over the solid region Q. And you're probably wondering, where would such a thing come up? And imagine a solid object that has a static charge on it, and the static charge could be different at each of the points on the inside. So that would be the function, and Q would be our solid region that has a charge on it. So further, if the length of the largest of the diagonals of the parallelepipeds was approaching zero, we could find the integral of the function over the solid from a Riemannian sum. And still further, if the function was 1, f of x, y, z equals 1, we could get the volume of the solid Q. So here's a definition of a triple integral. If f is continuous function over bounded solid region Q, then the triple integral of f over Q is defined as, here it is, the triple integral. Now it'll be difficult to describe the limits of integration, possibly, but not impossible. F of x, y, z dv, and again f of x, y, z equals 1. That would be describing the volume of that region with a triple integral. So we can think of it as the limit as absolute value of del approaches 0. Now that del represents the diagonal of the parallelepipeds, of f of xi, yi, zi, delta v. Now this is the volume of the rectangular piece, rectangular solid piece, sorry, the rectangular parallelepiped piece, the tiny box, and f is evaluated at some point in that box. And so del is called the normal partition, and that's the longest diagonal of the boxes. So f of x, I, y, I, z, I is a function evaluated at some point in the ith box, and delta vi is the volume of the ith box. So, and if the function is 1, then that's the volume of the solid region. So that sums up what we're going to be doing with triple integrals.